of how is the confidence interval going to be like. So then we have to determine the confidence level. Okay, so if my confidence level is 95%, so what does that mean? Do you know how to put it in words?
Yeah, 95% confident that the true population mean rate of whatever we are trying to find can be wrong
Okay,
definition.
listen
Hold on.
carefully, listen carefully. When I say my confidence level is 95%, okay, it means that if we were to examine many possible samples of mean, each of size n, then each sample mean will create its own interval. So that one, we call it confidence interval. 95% of this many interval will capture the true population mean and 5% will not. So that is the meaning of confidence level. Okay. So after you explain the meaning of confidence level, then every time when we get a confidence interval, we always will start with, we are 95% confidence that the true population mean of whatsoever you are talking about will lie between this and that. So that is the meaning of 95% confident. That means if we were to examine many possible samples of mean, the parameter that we are talking about is the mean, each of size n, then each sample mean will create its own interval. 95% of these many interval will capture the true population mean, and 5% will not. Okay. So why I say the one of the sample mean that we got, we want to take it as point estimator. So this is our one of the sample mean that we get. And according to CLT, our sample mean distribution, if the sample size is large enough, it will be normally distributed, correct?
Yeah.
So this is the center. Remember, this is the center. We assume this is the center. That's why I call this a point estimator. So that means my bell shape will look like this. Am I right? Yeah. So this is the center. So any normal distribution so is according to is the center. Okay, and the standard deviation will be what? Will be equal to what? Can someone give me? The standard deviation will be equal to what? Sample mean distribution?
Divided by root over n.
Yeah, will be equal to the population standard deviation divided by square root of n, correct? Am I right? So this is, all this is according to which theorem? Central limit theorem. Okay. So we also know that in chapter 8, all normal distribution can be converted to, can someone tell me?
Standard score.
Yeah, thank you. Standard score. Standard score, which is normally distributed. Yeah, may I know what is the mean of this standard score? May I know what is the mean of this standard score? 0. Good. I purposely ask question is to make everyone think, you don't sit there and dream, okay? Then Mikia, may I know what is the standard deviation for this standard score? What
One.
is the 1? Good. And what is the formula link between these two? Link between the X and the Z. Still remember? This is the formula.
No. X minus divided by n. Wait, I'm sorry.
Yeah.
Oh.
Okay. Okay.
Yeah. Okay.
So now I'm going to talk about this 95% confidence. Okay, so that means I'm going to take the width, center at my sample mean, and here is 95%. So can you tell me what is the lower Z score? What is the value of Z1? And what is the value of Z2? Can you get the value of Z1 and Z2 using your calculator?
Zero.
Hmm?
Wait, like zero.
How you get Z1 and Z2 first of all?
Z1 0.25.
How you get 0.25?
Wait, 2.5.
How can it be 2.5?
Is it?
If here is 0, below 0, how can it be positive? You tell me. I'm asking you. If here is 0, below 0, how can it be positive? So you definitely know your answer is not right.
Oh.
Am I right?
You're right.
Yeah. So you can analyze like that. Z1 must be less than 0. So Z1 must be negative value. So how to get the value if you know that the area is 0.95? Go back to your chapter 8, please. Can someone tell me how to get Z1 and Z2 straight away? Depend on your calculator.
You use inverse norm.
Thank you. We use inverse norm. So I use, yes, to get the value of the variable, always use inverse norm. Please, all this is talking about normal distribution. So I use inverse norm. So I put 0.95, comma, 0, comma, 1. And because it's symmetrical along the 0, correct? So I put center. Okay, this is one way of doing it. If your calculator don't have center, then you use inverse norm. Mikia, your answer is not right. Okay, so I put 1 minus, Mikia, your calculator, you need to do this. Divided by 2. Then 0, 1. Because this one always need to key in the area to the left. So this one you will get negative 1.96. Am I right? You only get Z1. So this is negative 1.96. And here is 1.96. So for whatever confidence level that I give you, to find the standard score for that corresponding confidence interval, you have to use inverse norm. Are you clear?
Yes.
Yep.
Mikia, do you get negative 1.96?
I did.
Yeah, so please remember that. Okay, now, so which means that my confidence, When I use this point estimator, I can estimate the lowest possible population mean, the highest possible population mean. So I let L be the lowest possible. So the corresponding value for L is negative 1.96, correct? So I'm going to apply this formula. So my lowest possible estimated true population mean, take away the center, that is my sample mean, one of the sample mean that I use, divide by the standard deviation of this sample mean distribution, which is this. This one must be equal to what? What is the corresponding value of the lowest?
Negative 1.96.
Yes, negative 1.96. So my lowest possible estimated will be equal to one of my sample mean that I use to find this confidence interval, take away 1.96 times this. So this is the formula. Hello? And this part of the formula, we call it margin of error. Margin of error, that means I allow myself to have this amount of error. So this is called margin of error. Are you clear?
Yes.
Okay, this one, I use different color. This part, we call it sampling error. The standard deviation of the sample means distribution is called the sampling error. The distance between one of the sample mean that you use to judge to find the confidence interval with the lowest or with the highest, that is called margin of error. Are you clear? So you have to get a very clear cut. Okay. So now I'm trying to get the highest possible value. So can someone tell me H minus what? Emily, H minus what? Over what? Equal to what? I must use H minus. Emily? Okay, X bar N divide by sampling error. Correct? So what is sampling error? I told you already, sampling error is the standard deviation of the sample mean distribution. Standard deviation of the sampling distribution. You can be sum, it can be mean, depend. So that is called sampling error. The error that you created due to sampling. Because some of the sample mean may be bigger, some of the sample mean may be smaller, correct? It may deviate from the population mean. So that's why we call it a sampling error. If it's talking about mean, that means sampling error of sample mean. Okay, equal to Okay, now we talk about here, equal to, so divide by the sampling error. Okay, equal to Junjie. Equal to what? Junjie equal to what? Junjie equal to what?
Wait,
Wait,
1.96.
thank you. 1.96. Okay, so my highest possible predicted true population mean will be the sample mean that I use plus the margin of error. Correct? So then we will have this formula that is stated in your textbook. Yeah. You see the formula stated in your textbook page? You see on page 270? So confidence level is 95. So your true population mean, your predicted true population mean, this is estimated true population mean will be between right? Xn, what is Xn here? Sample mean from samples of size what? And that is drawn from where? The population. So depend on your, what is your population. So in your book, they replace this by this. Am I right? So what does it tell you? It tell you that is the z-score. Alpha over 2. Your alpha is the one that is not. That means your alpha is referring to 100% minus. That means 1 minus 0.95. So this is what they call you the alpha value. Are you okay? Okay, so I interpret whatever your book tell you already. Okay, so good. So now, if I have different confidence level, I will have different value for this. Am I right? So if my confidence level is 95, the Z alpha over 2 will be 1.96. That means this is talking about the standard score. Am I right? So now if my confidence level is 99, can anyone tell me what is my Z alpha over 2? Will the value be bigger or smaller? Wing Shen?
The value would be, in this case would be, this is for lower, or it would
It doesn't
be,
matter lower, it doesn't matter.
it will be bigger and lower. It's like 2.58.
So can someone tell me what is the Z alpha over 2?
2.58.
2.58. Okay. So it will be 2.58. Right? Am I right? Okay. So now I ask you, so will the margin of error bigger or smaller?
Bigger.
So we will have bigger margin of error. Because our margin of error is this, correct? If I'm talking about same population, same sample, mean that I'm using and same sample size. So my margin of error will be bigger. So my confidence interval width will be bigger or smaller?
Bigger.
You are more confident, okay? But you are less precise. Agree with me?
Yep.
So, yeah, but if you are too precise, you are not confident also is useless, am I right? Okay, so I hope everyone know how to find the Z-score. Shall we try another one? If the confidence level is 90, so what will the Z-score be? Will it be bigger or smaller? You are less confident.
Smaller.
Smaller.
Smaller. Okay, can I know the value? Everyone start calculating.
1.64.
Okay, Stephanie, can I have the answer?
Yeah, Miss, my calculator is calculating it.
What happened to your calculator?
It's loading.
Loading. Wow, take so long?
Is it 1.64?
1.64. Okay, can you tell me how you get?
I used inverse norm.
Yes?
I used inverse norm. I put 0.901 and center.
Okay, so your calculator save you, Okay, new calculator will be better, correct? Less hassle. So you get 1.64. So you see, this one control the margin of error. Yep. Are you okay? So this is the formula. So why we have to know the formula? The reason is because in the exam, I may write out the formula. The question may write out the formula. Then they ask you, what does this represent? So they will ask you, what is this? So everyone have to know this is the margin of error at the 95% confidence level. So I can change this value. So confidence level, I can change. So if I replace here 1.64, you should know already. That is a confidence, there is a margin of error at the confidence level of 90. Are you okay? Can or not? So
Yes, Miss.
remember how to get the standard score for different confidence level. You don't have to know how to derive this formula, but it's good to know because if you write in your report. Yeah, that's why I have to explain. I can go without it one. Okay, so now I explain to you. You can explain to the one who read your report how you get this formula. Okay. Yep. So if I change the confidence level, the margin of error will change. So that will affect the width of the confidence interval. Okay. So you have to know the difference between these and this. So what do we call this? Rush? What do we call this? The one that I take in blue.
Sampling error.
Thank you. So I have to get it right. Because sometimes in the exam, I can say the sampling error is this value. I didn't give you the standard deviation. I didn't give you the sample size. I said the sampling error is this. And I give you the standard deviation. I ask you to find the sample size. Can or not? Okay. Then how about the one I tick in red? Huh? Silvana? Yes?
I'm not sure.
Silvana?
So
I just want to know. I just want to know one thing. When you are listening to my lecture or a tutorial or whatsoever, I went through it quite slowly, right? Did you write down? Did you put a note? Do you write down your notes, Silvana?
no, not yet, miss. I'm just listening.
Then when are you going to write?
Maybe at the end of the lesson or the end of the day.
You want to go through again. Instead of using 1 hour to learn what you're supposed to learn, you want to spend 2 hours. You see or not? That is the difference. Was I very fast just now, Silvana?
No.
I use 30 minutes to explain all this. So do I give you enough time to write down whatever you're supposed to do? So Silvana, tell me what is that called? Now I turn to the page already.
Margin of error.
Yeah. You see that is your that's why when I ask you a question, you can't answer me. Because you didn't write down. Your notes. Do you know what is the problem with nowadays? Do you know that? Okay, I just want to let you know. Okay. If you disagree with me, also can. Do you know when you listen, you write, you learn much faster? You stay more focused, then I provide you with the notes. Do you know that? When I was your age, I was studying in Park College. While our lecturer have lecture, there is no lecture notes at all. And every 1 hour, do you know how many pages we need to copy and also understand it? Minimum 5 pages. Minimum 5 pages. That's why you see how focused we can be. That's why providing you with notes actually is to make you less focused. Because you know what? After that, I can do whatever I want. The notes is there. You know, you got the recorded. Then what? Now you waste your 1 hour. You see or not? So I just point out two things. Why I want to introduce this formula? Because I want you to know which one is the margin of error. Margin of error, that means the highest you can go, the distance from your point estimator to the highest you can go, or the distance between the point estimator to the lowest that you can go. So this is called the margin of error. So the margin means the extreme. Are you clear? The extreme that you can go. Okay. Sampling error is the error that you get due to sampling. And do you still remember what is sampling? Can anyone? All these are very important words that you are supposed to put down in your report. Do you know that? Do you know why I keep repeating? So what is sampling? Anyone?
Looking at samples after samples of same size and from the same population.
With the same sample size from the same sample, from the same population. So that is called sampling. So the definition of sampling is very important. You have to write it down. When you write your report, you have to tell people why you need to do sampling. So what is sampling? So these are the things that you need to explain. Do you think Ms. Loeb do it for fun? No. Okay, so now I want to go to example 6. Okay, example 6. You see example 6 on page 272. Okay. Okay. So it's quite simple. If I just want to answer this question, I just get it from the use the calculator, just punch in the number. Okay. So in this question, may I know what is my population? Okay, can someone give me what is the population? Every problem that you have that is given to you, you have to know the population. Okay. Adrian, tell me the population for this question.
Is it all the yabbies taken from a dam?
Yes. So it's the yabbies from the dam. You are right. Okay. Next time, if you are using this one, as then you define your population, you name the dam. You see or not? Okay. Now, what is the parameter that we are going to talk about the population? Parameter of interest in this question is Kelvin?
The mean weight of the yabbies.
Yes. Thank you. You see? Very important, huh? Parameter of interest is the mean weight of yabbies from the dam. All right? Okay. So get it? Okay, so what is the value of one of the sample mean? Is what? 84.6 gram,
84.6.
correct?
Yeah.
Okay. So what is the sample size?
60.
Okay. Now, is this sample mean distribution normally distributed?
Normal.
I can turn this question into your exam question like that. Huh? Is this sample mean distribution normally distributed?
Yes.
Explain. Is this sample mean distribution normally distributed? Explain. Okay. Kydrick? Long time I didn't call your name. Kydrick, answer yes or no?
Yeah, because it's
Yes.
more than 50.
Yes. Why?
Because according to CLT, it's more than 50.
Yeah, because according to CLT, according to CLT, and which is 60 is more than 30, correct? So you will be normally distributed despite whether the population is normally distributed or not. Yep, there's two ways of answering this. Huh? Okay, so given that the population, okay, now what? So now I slowly, I'm not interested, I'm more interested in how to create question from here. So what is the margin of error? You see, Ms. Low can straight away create the question. What is the margin of error? Okay, by the way, the confidence level is 95, correct? Okay, what is the margin of error? So what is the formula that we are supposed to use? Remember the formula? Yes? Ramisa?
Yes, miss.
Yeah. How to find margin of error?
Z alpha by 2.
Yeah. Okay, what is your Z alpha over 2 if the confidence level is 95? Hello? So look, margin of error, do you know I can get it in two different ways? Okay, who can think of how to use your calculator to get margin of error? So it's 1.96 standard deviation over square root of n, correct? Yeah, so it's 1.96. The standard deviation of the population here, is it given? Ah, 16,
Yes.
yeah, 16.8,
Mm-hmm.
correct? So square root of 60. So this is your margin of error. Okay, who can tell me how to use GC to get margin of error?
Inverse norm.
Inverse
Wait,
norm.
wait,
How to
inverse-
use
wait,
inverse
wait.
norm?
Wait.
You
Is
don't,
it
you
interval?
don't have this and this. You inverse norm only get this.
Oh yeah,
So
wait, that
check.
is true. Hold on. I'm dumb. Hold on.
Okay, how to? Okay, so now I'm going to tell you that everyone take out your calculator. Still remember yesterday I teach you how to count confidence interval?
Oh, a new method.
Z interval.
Yeah. Okay, can you please? So this is your confidence interval. Everyone, okay, so actually it's in your book already. If you get your Z interval correct, you get 80.3 and the other one is 88.9, right? Hello? So from here, can I get margin of error? From here, can I get margin of error? Can I get margin of error from here?
No.
Why not?
Wait, where are you referring? I cannot see where you're pointing.
Here.
Where's
I'm
here?
referring to this one.
You mean the...
Can I get margin of error from here? From the
Yes.
confidence interval. Can I get margin of error from the confidence interval? Jared Wong?
I'm not so sure, miss.
You try not? Do you get the answer from here? You get the answer from here, then you try? You're not so sure. Definitely you are not so sure, but you can try what? Can you? 1.96 clear. 1.96 times 16.8 divided by square root of 60. That is my margin of error. That is 4.25. Now, can I get margin of error from here? Look. Okay, let me go to here. You know this is the center, correct? From the center go to the lowest is the margin of error. From the center go to the highest is also the margin of error. So the difference between the highest and the lowest is 2 times the margin of error, correct?
Oh, you are right.
Definitely I'm right. You are not observant because you are given too much already. That's why nowadays I purposely don't want to tell. So Jared cannot say, I don't know. You have to try. Then only you can be creative. Okay, so Jared, can you tell me how to get the margin of error from here? Jared, tell me. Okay, I do halfway for you already. You please do the other half. You are lucky to be picked. Faster, Jared.
Is it the...
Okay, give me the number. Just say it. You won't die, okay, for saying the wrong thing. Yes.
4.25?
I know it's 4.25. How can I get 4.25 from here? You please tell me the step, can or not? Here I know it is 4.25, but I want to get it from here, I don't want to use the formula. I want to get it from the confidence interval.
Oh, is it the 88.9?
Yeah.
Oh.
Then?
do I have to
Just try lah.
minus 80.3?
Yeah, okay, good.
Yeah.
You try and see? See whether you get the same as this or not.
Yeah, I get 4.3.
Around that lah, because
around
this
that.
one is round off already, correct? So
Yep.
you get 4.3. So what am I trying to tell you is here? What am I trying to tell you is here? There are many ways to get the answer, right? Am I right? You can go by formula to get margin of error. So people can give you the confidence interval and ask you to find margin of error also. See or not? So is that the only way to find margin of error, class? Is this the only way? Is this the only way to find the margin of error?
No.
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 So, yeah. So you want to find the margin of error depend on what I give you. If it's given this, I also can find margin of error. So exam, I can give you anything. I can give you the confidence interval and ask you what is the margin of error. And I can give you also the margin of error and ask you to find what is the sample size. You see what I mean? Hello, class? So, number 7. Okay, if you look at example 7, can you please look at example 7? Okay, does the question give you the sample mean? Is there a sample mean given by the question?
Yes.
Sure. May I know what is the sample mean?
Isn't it 15.9?
How you know it's 15.9? I say the question, I'm not talking about the answer.
No, there's not. There's no.
There's not, but they got give you the data of a sample. Am I right?
Yes.
So you have to find your own sample mean. So for this question, you have to find your own sample mean. You know how to use your calculator to get your sample mean? Yeah, you key in, then you use one var stack. Is there a population standard deviation given? Is there?
No.
No. So you
The only
take,
thing we know is sample size.
yeah, the only thing you know is sample size and the data of the sample. Am I right? So if standard deviation of the population is not given, you take the standard deviation of this sample as the estimation of the population standard deviation. So take note, if population standard deviation is not given, use the sample standard deviation that is as an estimation of this one. Are you clear? So this is the facts that you don't keep saying, Mr. I can't find. So these are the few things that you have to take notes. Yep. Hello, class? Clear?
Yes, miss.
Okay, so tomorrow I will explain how to find suitable sample size. Yeah. Okay. So
Alright.
you can try exercise 8D.1. You can try exercise 8D.1. Yeah. Okay. Thank you, class.
Thank you, Miss.
Miss,
Yes.
Miss, how since I was late in class, how can I key in the attendance?
No way. No way you can key in the attendance.
So will I be absent, right?
Yeah. What may I know why are you late?
Yes, Miss, because I misread the schedule today. Like since Malaysian time is 1 hour ahead of me, so
Oh,
I just
so?
confused between the two. Like it never happens, but it happened today. I'm really sorry about it.
Okay. So I will change the attendance for you.
Okay, Miss.
Ramisa, is it?
Yes, Miss. Thank you.
Mm.